All right, so chapter 11 is on water and solutions. All right, so water is an essential resource. So this is going to be the percentage breakdown for home use. So this is the household percentage of water being used within homes. 2% is being used for drinking and cooking. 6% is used to wash dishes. 11% is used to wash clothes, so your laundry. 23% is for bathing, so that's your shower or your bath. 29% is the flushing of the toilets, and then 29% for lawn and garden maintenance. All right, so water supply is obtained from streams, lakes, reservoirs on the surface, or from groundwater, which is pumped from below the surface. All right, surface water is more contaminated than groundwater. Does anybody know why? All right, so the surface water is pretty much what we have access to. So that's where your pollution is going to be. So any type of waste, plastics, chemicals, pollen, any type of other, runoff, pollution runoff can go into the surface water. This is why the groundwater is actually safer to drink than the surface water. But with all the fracking and stuff going on, that's groundwater sometimes can be just as dangerous as surface water. All right, so properties of water. We know that it is essential for life. Foods are mostly made of water. So fruits and vegetables contain up to 95% water. Meat contains up to about 50% of water. Your overall body weight, 70% of your weight is water. And since water is such a large component of living things, understanding the properties are very important to understanding life. All right, so water in its liquid state has a greater density than solid water. So this goes back to the density uh, definition that we were talking about. So water is more dense than ice. That's why ice floats on top of water. All right. So if the reverse were true and ice was more dense than water, then the ice would sink to the bottom of the glass and the water would float on top if the reverse were true. But since water in its liquid form is more dense, that's why the solid ice, floats on top of the liquid water. All right, so your water molecule is made up of two hydrogen atoms and one oxygen atom, and they're held together through covalent bonding. So H2O is the molecular formula structure of a water molecule. All right, so universal solvent. So one important property of water is its ability to act as a solvent. So water is called a universal solvent because most other chemicals or molecules are able to dissolve within water. So salt, which is NaCl, it can be dissolved in water, more so in hot water than cold water. All right, so in living things, these dissolved molecules can be transported from one place to another by diffusion or some sort of circulatory system. Okay. On to solutions. So a solution is a homogeneous mixture. So it can be made up of ions or molecules of two or more substances. And those substances, when they're present in large amounts, this is what we call the solvent. So the solute is dissolved inside of the solvent. So one of the components is liquid, and that's what we call the solvent. So it's the large portion of the solution. And then fluids that mix in any proportion are called miscible fluids, and immiscible fluids do not mix. So an immiscible fluid mixture will be oil and water. Okay, one sits on top of the other, they don't actually mix together. On to concentrations. So concentration, this is the amount of solute inside of the solvent. And again, the solvent is going to be some sort of liquid. All right, so your concentrations are measured in parts per million or parts per billion. Sometimes it's even measured by the percent per volume, the volume of the solute per 100 volumes of solution, and then percentage by weight. All right, as well as the salinity, so the mass of the salt in the solution. The molarity, which is denoted by capital M, this is the concentration, or is defined as the number of moles of solute dissolved in 1 liter of solution. All right, so your molarity is the number of moles of the solute divided by the liters of the solution. All right, so on to saturation, solubility, and electrolytes. All right, so a limit to dissolving solids in a liquid occurs when the solution is saturated. So that means nothing else can be broken down inside of that solution. A saturated solution is one with equilibrium between solute dissolving and solute coming out of the solution. And then your solubility of a solid is the concentration of the saturated solution at a particular temperature. All right, so sometimes you have things that dissolve better with higher temperature, like salt. So if you're boiling water and you add salt, it'll melt quicker or break down quicker than just a cold glass of water and you're adding salt to it or sugar. All right, water solutions that carry an electric current are called electrolytes. All right, and conductors are called, non-conductors are called non-electrolytes. All right, so on to the properties of acids. All right, so here we're going to discuss the differences between acids and bases, and we're also going to talk about the pH scale as well. All right, so acids, they have a sour taste to them. So if you think of citrus fruits like oranges, lemons, grapefruits, things of that nature. Acids change the color of certain substances as well. Acids can react with metals such as magnesium or zinc, releasing hydrogen gas. And acids neutralize bases, so they can form water and salts from the reaction. So on to properties of bases. So bases have a bitter taste, so they're kind of like caffeine. Bases reverse the color changes that were made by acids. And basic solutions feel slippery on the skin. So this is what is used to make soap and glycerin. Bases also neutralize acids, forming water and salts from that reaction. All right, so acids have the sour taste. Bases have the bitter taste. Your base solutions are very slippery on the skin. All right, and bases can neutralize acids. All right, so an acid is defined as any substance that is a proton donor when dissolved in water. And a base is the opposite. So it's a substance that is a proton acceptor when dissolved in water. And the modern concept of acids and bases explains why properties are neutralized when they are mixed together. So an acid can neutralize a base and a base can neutralize an acid. All right, so on to the pH scale. All right, the pH scale is the strength, so how acidic or how basic a substance is. All right, so how it's expressed is using the ranges of the pH scale. So the pH scale ranges from 0 to 14, with 7 being neutral. All right, so in the middle of the pH scale is water. All right, water is around 7 pH on the pH scale. All right, so your acid solutions are below 7 and your base solutions are above 7. All right, so here are some examples of the pH scale. All right, so acidic is below 7, and basic is above 7. And then right in the middle, which is neutral, around 7, this is going to be water. Okay, so on the acidic side, we have battery acid, we have lemon juice, wine, rainfall. And then on the basic end, we have baking soda, soft soap, ammonia, lye. All right, so this is the stuff that feels slippery on the skin. And on the acidic side, this is the acidic tart taste that you associate with citrus fruits. All right. Okay. So that is the gist of chapter 11.